office in Manchester. And thank you for giving us the time. Really appreciate it.
Thank you for inviting us.
Absolute pleasure. So we're going to obviously talk about data science. We're going to talk about cloud architecture, talk about you guys and your sort of journey over the last few years, and maybe also talk about clients that are looking at taking on a data science project for whatever reason, the whys and wherefores, and the things that they need to consider when going on that journey.
Sounds good.
Yeah?
Cool.
Okay, super. So first of all, Joe, tell us a little bit about your kind of career history, where you've come from, and kind of where you are now and where you want to be, or where you see yourself in the next few years.
Yeah. So I guess historically, I always liked not doing just one thing. So even back in GCSEs, A-levels, I always liked having maths and computer science as two separate things. When I was sick of maths, I do computer science. Then when I got sick of the computer science, I go back to the maths. And that continued, so I went to university and I did computer science and maths at university as well. Found I really liked seeing sort of the visual side of data, the visual side of websites. It wasn't enough for me to run a program and see a little tick at the end. It had to be something better than that. It had to be something visual or something spectacular. So I moved to front-end development, started making websites and stuff, and eventually found my way to laterooms.com. And there, one of my close friends, Dom Duxbury, was sort of the first data scientist that they had, but not officially. I guess this is common in companies where there'll be one person that starts to look into machine learning and data visualization and dashboarding and accidentally becomes a data scientist. And I think off the back of that, that's sort of how John was sort of sought out as the first data scientist. I'll leave that to your story.
Yeah.
So there was a new data science team at laterooms.com, and Dom decided to go do a PhD, and I was thinking, maybe I should do data science. And we sat down and did this. There's a very famous data set called the Titanic data set that has the sort of ticket numbers and the names of all the people on the Titanic and whether or not they died. And you have to use that and predict whether or not they died. And the really interesting thing is because it was quite a sort of chivalrous time, the women and children mostly survived. So you could do a really naive AI or machine learning model that would only predict they survived if they were a woman or a child and assume they died if they were men. And I think that gets you something like a 70% accuracy. And this was sort of the first time I did something very complicated, but at the end you just get one number at the end, and I was like, this is kind of cool. And like, how can I extend this? Wow. And so I applied to the data science team where John was the boss, and I managed to get that John to talk about that previous one. And then after that, I went back to front-end development because I found the data science industry so difficult. The way recruitment is done at the moment, it seems like all these big companies don't really know what's going on, and then all the little companies will sort of read one or two blog posts and they'll have like a very, very slim view of what a data scientist is. So, you can fail interviews on questions like, what is this particular type of model, when really that might not be relevant, or recruiters might ask you what algorithms have you used in the past, and I'll be, there's questions like that where I'm thinking, if you're asking this, I don't think you really understand what data science is as an industry. So I felt very frustrated and went back to front-end development. And then from there, I sort of got poached into a startup where I'm now a data scientist, but also a project manager, but also a front-end developer. So I'm sort of doing a little bit of everything. And then after that, me and John have sort of got a company together where we're doing product development, but we'll talk about that after John.
That's great, thank you, Joe. Do you find that your front-end development experience has helped you then? With your data science?
Yeah, I would say so. At the moment, I think data science is this big overarching title of what is really maybe 5 or 6 different jobs. I think included in that is sort of data analytics, machine learning, data engineering and stuff like that. The data analytics side encompassed in that is data visualization. And I think if you can have your data visualized in a front end that people can see, I think that's really powerful. So dashboarding is a huge part of that data visualization, of that data analytics subset of data science as a job. So I think it all fits in together. And I think a lot of companies, while they're looking for one data scientist at the moment, they should really be looking for 2 or 3 people that sort of fit all those different jobs. And so I think it's helpful. This is one of the reasons why me and John kind of work so well together, is because John's more deployment, back end, machine learning, and I'm more of a let's look at this data, let's ask these questions, let's solve the problem, and let's visualize it in a way that actually shows us value at the end. So between us, it works very well.
And so that's, John, really you're more of the architecture side of things then?
Yeah, I'd say so.
And your journey, where did that
my journey?
start?
Well, my journey is similar, I guess, but different to Joe's. So I was driven, I guess, more by curiosity through school, and again, I grew up in Manchester. Not renowned for its farming, but yet I ended up doing a PhD in the molecular genetics of wheat.
Oh wow! Okay.
Yeah, which is quite a weird path to take in the first place, and got into doing some basic machine learning as part of my PhD,
Right.
and some friends who were developers, and then at the end of the PhD, I kind of thought, well, data science seems like a good thing.
Yeah.
And it seemed interesting for me, and it seemed an awful lot of businesses need this and could benefit from it.
Right.
How hard could it be, I thought. So off I trot, and I started applying to a couple of companies, and luckily, and there was a good amount of luck, there's just in the cusp of when data science was a big buzzword, but people were still very nebulous about what kind of things it could do.
Right.
So I was there, I knew quite a bit about machine learning techniques, I knew quite a lot about science, I did a PhD. So, I was in a good place, but I was able to go in and then start working at Laborings, kind of with with Don, who was an intern at the time.
Yeah.
Pick up from him what he'd been doing on a technical level. Pick up from the directors what strategic objectives they wanted to understand, wanted to achieve. Work with the data guys to figure out what we had, what resources we could use, and then say, oh, okay, oh dear, well, this is right back to the drawing board then.
Yeah.
We need to figure out how things will work. And it wasn't actually at all about these are the right algorithms to deploy, or these are the treatments and controls, or scientific, or things that you see more in scientific statistics. It's more, how can you solve this problem?
Okay.
And that's where speaking to a lot of infrastructure, operations, developers, architects, that's where all that came to be absolutely paramount in figuring out how we could achieve our goals. And that's kind of where where I came from, as opposed to a heavy dose of science, a heavy dose of development, but really it's about how we're going to operationally solve these problems. And not to ramble on about it too much, but it's
that's why you're here.
okay.
Fine.
Well,
No,
ramble on massively. So DevOps is a massive deal, and quite rightly so.
Yeah.
But DevOps in a machine learning scenario is it's not completely different, but there's a complete dimension in there, which is data, which is usually not relevant in a regular software system.
Right.
I mean, obviously there is data, but not in the same situation as you have. So making sure that you have the right type of data, the right format, but within the right distributions, and it meets all the assumptions and constraints that you use when you train your model, or that you use when you design your model. That isn't something that regular DevOps has an answer for. So it's been really cool, chatting to people both coming from infrastructure, operations, DevOps kind of focus, and data scientists in Manchester, who are also trying to figure this one out.
Right. Okay. That's interesting. So it's the sort of science behind it, but then the architecture very much go hand in hand. And in your experience in the last few years, have you seen the kind of advances in cloud computing make a big difference, I'm guessing?
Yes.
And that's to what you can do physically? Is that a bit of a silly question? I don't know.
Oh, no, I mean, I think it's, again, with so many of these subjects, both big data, cloud computing, there are so many buzzwords and so many case studies you never know who to trust. I found that it can be transformational just because it's easier to get things up and running and to try things out quicker to see what will work in an operational situation. When you're working on an on-premise data center, there are all kinds of constraints that may well that can be there quite rightly, and there can be constraints that are there because it's politically expedient within the organisation to do so. That raises difficulties about what you can and can't do. Those are usually very different constraints in the cloud, and with the cloud, because if I'm using AWS or GCP, and the same person in America is using AWS or GCP, so lots of different people are looking at and trying to solve the exact same problems, whereas your own bespoke architecture at home, that's just you and your problem.
Yeah, okay.
There's been a lot more data tools appearing in Google Cloud Platform and AWS as well in the last 2 years. A common new one is AutoML, which is you let the cloud platform do all of the training for you. You just provide it the data, tell it what the target is, and it does that all for you. So it kind of seems like they're trying to take the parts of data science that I guess we enjoy and make them the automated parts. It's a weird one. You always think of like data science-y jobs as being one of the last ones to get automated, but now you're seeing like there's so many data science people in the sort of cloud industry that it's a huge, I don't know the word for it, like it's a huge slice of their pie, I guess. So they're building many products for data science type of people.
I was talking to a data scientist the other day that we were helping find a job, and he was talking about what the next big things, and he was talking a lot about automated data science. Is that what you? Is there a certain irony around the fact that that so many of these tools are going to automate the process that a data science would actually do, or a data architect might do?
Well, do you want to get this one, Joe?
I don't think it's a bad thing, because I think there's a common saying in data science that like 90% of the data is 90% of the work is like munging through the data and doing like the boring bit so you can get to the fun bit at the end. I think a lot of this empowers that boring bit at the start, and as Tom Liptrop says, that 90% of it is 90% of the job. It's not the boring bit. The job is 90% doing that stuff. So if it facilitates any of that, I think that's great, and I think it frees up time. I don't think data scientists are the people that are gonna, if we take away the machine learning part of it, I don't think they're gonna say, oh well, that's all I could do. Data scientists, sort of as a role, we do whatever is relevant for the job. If there's a people side of it, like John was talking about, where you have to work with stakeholders and stuff, but you're still in the data domain, that job's still going to exist for quite a long time. So
yeah, I mean, I would say the key skill of being a data scientist is communication.
I was going to come to that because, and it's becoming more and more apparent now that you've talked a lot about the back end, or the initial analysis work, and then the visualization. John, you've talked about the architecture, but I think a lot of people forget that you need a stakeholder management process. You need to have people that are engaging, that are going to be able to talk to people within the business who probably have never actually looked at data in their life. So we're dealing at the moment with a very, very large organisation who are trying to look at their logistics and their supply chain and their manufacturing businesses to see where they can improve and be more profitable. And they've said, we want a team of data people that can go and talk to somebody on a warehouse, in a warehouse, and go, right, what are your problems, what are your challenges, how can we use data to solve that, and then create a dashboard that not only tells the data scientist what the problem is or what they need to do, but actually somebody in a warehouse can go, oh yeah, in my language, I know exactly what that means now. So dashboarding's massively important, but to get there in the first place, you need somebody who's going to be able to, a bit like a business analyst would do in a development project, right?
Yeah.
You've got to use the entire product team. It's very rare that you can go in as a data scientist and you alone can solve the issue. Usually the problem is ill-defined. The company knows that they want to make more money, or they want to be more efficient with the use of trucks and whatever in a logistics. I don't know enough about logistics companies to know what those problems are, which is exactly the point.
Yes, yeah.
You need to have business analysts or whomever to help understand the business problem and convey it. You need to have UX people who can help understand how best to convey the information to someone working in a warehouse. What information do they need to make a decision that's going to be more efficient for them and the company? Is it a dashboard? Is it something else? I certainly don't know. But the best way of doing it is speaking to them and figuring it out. And you've got to have the communication. You've got to understand all the way through, because much as it's fun talking about algorithms, it's fun talking about the back-end architecture. If you can go in and say, oh, actually, we spoke to the BAs, we spoke to UX, we spoke to CTO, we spoke to the forklift operator, the best way is we can take the average over this 5-second span and send you an email, and then you can make the right decision. That's the way to do it. Don't do anything fancy. It's solving the problem.
Yeah, we found that at Laterans a lot of the job was, I always described that job as we were internal consultants, because we had big projects that we were working on, but there was always downtime while you were waiting for someone to prioritize the work that you were claiming would make them millions. It was a really strange like back and forth. So we were always like going around to like weird, you know, like to the marketing team or to the contact center team, and we found that the more assumptions we made, the more we got it wrong, right? Like if we looked at things, we would discover things that I would then delete because I'd be like, we can't say this because we're not confident in this. And then we'd go back to the data and we'd find out that all that data was collected after some other thing. And if we went forward with the conclusions we originally had, there would have been like huge consequences.
Oh, wow,
and it all came off these bad assumptions because column headings were incorrect or were just useless. So it's so like end to end, you can't do
so you
any
put
of
bad
this
data in, you get bad data out.
Yeah, no one ever has good data.
Yeah,
It's understanding in what way it's bad, how you can use it within how bad it is.
Okay. And so one of the other questions I was going to ask you was about this contentious discussion right now about Google Cloud architecture versus AWS versus Microsoft Azure. I think I was reading today, everybody talks about AWS, and obviously they've got a lion's share of the market. I think it's something like 51% of the market right now. Then Azure has about 17% of the market. IBM, who really nobody talks about, they've got 11% of the market, and then Google Cloud, they've only got 6% of the market right now, apparently, but that's a 125% increase year on year.
Okay.
So they are really, you know, the late to the party, but everybody I speak to seems to be talking about how much more flexible it is, it's open source, when you get the data in you can do a lot more with it, and a lot of talk about TensorFlow. Do you guys want to kind of, what's your take on that?
So I'm quite surprised that Google Cloud Platform has such a low market share, albeit they certainly were the last to the, I think they're the last to party as well, but it doesn't surprise me they're making such big gains year on year.
Yeah.
I've certainly found it's easiest to use them. I've not used AWS extensively. I've used Azure for a couple of projects, and I've used GCP. Now all of them that I've used did the job. Got no major complaints about any of them. But I found the UX of Google Cloud much easier than else, and it's very easy to get going and get a project running. Yeah, I do appreciate the fact that there's so much involvement with open source, but I think at a certain point, like we were saying earlier on before we started recording, it's a case of there's a lot of similarities, but understanding what the best tool is for your business based on where you are.
Yeah.
Now, I think feature parity is the term I'm looking for. Wherever one of the three cloud providers will come up with a brand new feature, and it'll be game changing, revolutionary, something that no one else can do. But within 3 to 6 months, one of the competitors will still have produced something on their own platform that can do that. So, AWS had it's not cloud functions. AWS. Anyway, yeah, AWS Lambda. That's the name I'm looking for. AWS Lambda and Azure functions and Google Cloud functions are available now, and I don't think that's something that people are of the industry as a whole is adapted to kind of figure out how to change architecture to make the most of.
Yeah.
But once you start taking advantage of those and understanding how different serverless components as well as compute components on your cloud can be joined together, that's where the real value lies. Right. If there's more, if for example, this is very much a hypothetical, if AWS's Lambda functions are cheaper and quicker and more efficient, but it doesn't tie in so well with their Kinesis, I always think of like a message queue similar to Kafka, whereas Google's PubSub may tie in better to the Google Cloud Functions.
Yeah.
Now it may be slightly more expensive or slightly slower, but if that all works together and fits together as a framework better, it can be more efficient to maintain, save on operational costs, and save on uptime. So it's about understanding how things work together rather than having one thing or another. I think that's how I think about it.
Yeah.
And also, I don't think vendor lock-in is as much of a thing to be worried about in general. answer.
Well, if the company or a Microsoft house, they've got a development team, all .NET, running C#, or whatever it might be, then they're going to naturally go to Azure, aren't they?
Yeah, and to be honest, I think that's a natural place to start.
Yeah.
But at the same time, you probably don't want to spend too much time comparison shopping to get your first project out to understand it. But having used Python across all three cloud providers, none of them specifically cater for Python, but none of them are specifically Python houses, but even Azure was very good with documentation for how to get going with Python.
Right, absolutely. So Joe, your take on what John said before, AWS, Azure, GCP, what's your take on it?
So it's really common in software development to have these weird, like very petty wars between software choices or framework choices.
Yeah.
And front-end development is so famous for having React versus whatever the other ones are. You can tell I use React.
Do you really?
So you'll see the same kind of thing with this AWS Google Cloud Platform. It's so weird the Google Cloud Platform is even in the discussion if it's so small, but I think it's rightfully there. Having used it, I think the user experience of Google Cloud Platform is incredible compared to the other ones. The documentation has code snippets in Python. I'm pretty sure it has C#. It has multiple. It was always easy to kind of do what we wanted to do. And I think, like you guys were saying before, if the company you work at uses a lot of Microsoft tools, it might make sense to use Azure, because I would assume they have plugins for whatever other Microsoft tools you use. If you're using Office 365, I would assume I can automate something in there using something in Azure. Now the thing is, as a front-end dev and a data analyst and a data scientist and all these other roles, the most common tool I would use would be Google Analytics. And so I assume whatever cloud platform I use needs to be able to work very well with Google Analytics. And obviously Google Cloud Platform does that very nicely as well. So you can export your entire Google Analytics history to Google BigQuery. And it just makes everything really easy. And whenever Google does their take on something, when they do Google Places for travel, they always do it with, there was millions spent on user experience research and testing and making sure everything makes sense to everyone. And I've always found, AWS, I think appeared like 5 years before Google Cloud Platform did. So it makes sense that it's got this huge share. And it also makes sense that, if I have 5 years experience with Python and none with R, it makes sense that if someone new joins the team, I could you're going to learn Python because I like Python, but R might be the better choice. And I think that's what, maybe I should have flipped this. I'm not gonna poo-poo on R now. But it's that's the way I see it. Like, Google Cloud Platform is coming in, offering this feature parity, and at the same time they're doing it with a better experience, and it really plugs and plays with everything that I would ever expect to see as a front-end developer. So it all just makes sense to me. Don't make any other notes. There's a better free trial system with Google Cloud Platform. Okay. If you're a small company, I think you get $300 credit every month until you start going over it or something like that. There's no end to that free trial period now. Right. I think AWS is a year.
Yeah, I know a couple of people have got that. I'm not sure how.
Yeah, I've never paid for Google Cloud Platform, but I've used it for my personal projects. So it's when you're in a big industry, obviously $300 a month is nothing.
Yeah.
You will go way over that with your cloud costs, but that's, if you're a hobbyist, if you want to learn something, that's a great way to do it. You shouldn't, in my eyes, if you want to learn how to use something like Google BigQuery, you shouldn't have to put your credit card in and be worried that you're going to get charged as an individual for trying to skill up and learn something for your industry. Google Cloud Platform is apparently cheaper on average. Don't know. And AWS has more data centers, so maybe it's faster, but that's all my notes. But I think that 5-year head start is key for AWS.
Yeah.
But I used AWS, must be like 4 or 5 years ago, and I remember thinking, I should get qualified in this. This looks like the new big thing that's going to be really cool. I could be the member of the front end team that's doing the deployments and stuff. And I remember going to the product page, and there were about 100 things, and the icons all just reminded me of they were like the old style AWS icons, and it's a really weird reason to look at a cloud platform and go this kind of sucks, but it was the front end that really put me off. And with Google, everything was just nice and everything was easy, and you can tell the same way I prefer React as my framework. I do prefer Google Cloud Platform, so it may be slightly biased, but I'm a fan.
So they're late to the party, but they are typically in Google fashion, they're getting it right then.
Mm-hmm.
Yeah.
So.
Okay, interesting. Obviously, we're kind of talking to you guys about partnering with our clients to offer our clients a little bit more than just, can we come along and talk to you about your jobs? We have always kind of said that we're about helping companies build their data teams, and it's not just about putting a bum on a seat, and it's not just about sending them CVs with lots of different buzzwords. So we want to work with you guys to help our clients basically get that recruitment right, and it not just be about the pre-screening of candidates, although that is something that you obviously are going to help us with, but it's actually going back right to the start and actually asking the client the question, what do you want to get from the data? And you mentioned it earlier, John, about what does the client, what's their objectives, where do they want to be, what questions do they want to ask of this data. So do you want to just sort of talk a little bit about the experience you've had recently with companies that perhaps have benefited from your consultancy services?
Should we introduce what PDFTA is?
That'd be great.
Yeah. Do you want to go ahead and do that?
Sure. So PDFTA is, at the start, we are a end-to-end data product development house. So ideally we want to make products ourselves. We're currently working on a recommendation system, and we think it has to be, like Google Cloud Platform, it needs to be plug and play, it needs to be easy to pick up, and we think that that's what a lot of people are doing wrong. If we then after that, we're a data consultancy, so maybe we'll make those end-to-end products in-house for you if that's what you'd like. And then at the same time, I'm looking at attacking the same sort of problems from the recruitment perspective, so working with you and maybe other recruiters to tackle things like, why do we interview the way we interview right now? Are we pushing out the best candidates by the way we interview? And like you say, going into those businesses and saying, what do you actually hope to get from a data scientist? Is there one project that you're talking about where maybe a good data scientist could do that in 5 days, and you should be looking at paying a contractor instead of putting down 60 grand for some head of data science and building out this whole function? Or are you not even ready to get there yet? So that's kind of what PDFTA is looking at doing at the moment. What was the rest of the question?
So yeah, I think the rest of it is looking at when you say to business, okay, well, what do you want to get from the data? I'd say even take it a step back from that. So what do you want to get? What are your problems? Where do you want to be in whatever 5 years? What is stopping you? And just have that conversation on a business level. Because once you understand where someone wants to go, you can start looking into the data. Because if it turns out most of their objectives are unrelated to data in the first place, then you can kind of stop someone and say, okay, well, right there, you may think that data is a data science or machine learning project is a good idea, and I obviously think that often case they are. But if someone wants to get involved in it, but it's not going to help them main priorities for a business, that's not something that's going to help their business overall. So really starting from the top, then understanding, going right down to the bottom, what basic resources are available, what data do they collect, where can we access the data? So in an e-commerce situation, someone wants to predict the likelihood of a new visitor to the website and making a purchase on that exact on that site visit. It's all well good having a huge amount of information in the back end, but you need to be able to get you need to deliver a solution that can also have surface the data at the front end, so the the UX team and the front end developers can do something with it. So there's all these constraints about where the data is, what it contains, but also where you can use it. And once you understand on a high level what a business wants to achieve, and medium-ish level, you don't need to know the ins and outs to start getting some ideas about the data. You can start saying, okay, this is what we can do. This is how we go from what could be a mammoth task that can deliver millions of pounds of value, and break it down into small tasks of one little bit here, and this will help build a foundation that will take you to where you really want to get to.
And typically, the sort of size of company or the type of company you're talking to, what does that look like for you guys?
So I mean, I think
mostly smaller ones, really.
Generally, SMEs. Generally, we've looked at e-commerce companies and a couple of IoT companies. But again, I've done a little bit of speaking with local government, and they have completely different problems with data, and they're facing completely different challenges to businesses.
Yeah.
So it's really interesting learning from them as well.
Yeah, I was talking to a local authority that are looking to adopt data around littering, which again, like a completely different problem. It's not about making money or saving money. This is there's new laws that have come in recently. You now will be fined £150 if you litter, but there's still littering, there's still fly tipping going on. How do you catch people? So there's a company that we're talking to at the moment. They've got a patent to actually identify these people that are actually littering and using data and artificial intelligence to then send a message to a local authority person with a mobile app that will get a notification and video evidence of a car fly tipping. There's their registration plate, and being able to issue a fine. It's real world problems and challenges, and it's not just about companies wanting to make money or save money. So you're right.
Oftentimes,
public sector is completely different challenges.
Completely different. I would never have thought that fly tipping and bin collections are such massive issues to government, but they are, and they are often more difficult problems to describe in a mathematical sense than we want to optimise the amount of money we make, which is an easy to understand how to achieve. But with government, it oftentimes much more nebulous. But this is where you really need to understand the problem, understand the business domain, and figure out how they can do something to actually help in the meantime, because they don't have millions of pounds to spend in budget either. So it's figuring out a solution that will work for them.
What's your opinion on kind of ethical data science? So it's not something that I think a lot of people are talking about at the moment, but if you've recently watched the Netflix documentary, The Big Hack, was it The Big Hack?
I think that's right. I've not seen it yet, I've read about it.
And it's all about Facebook advertising and how they're manipulating people's minds and propaganda and all this sort of stuff. Where do you see sort of ethical data science coming to? Because we talked about customer acquisition, this is what people want, but we all know that it goes on, but then we're kind of surprised when it happens to us a little bit.
Yeah, I think it's something.
And data is pushing that, isn't it?
Yeah.
Yeah.
Oh boy.
I think it's something we need to take incredibly seriously.
Yeah.
Because the thin end of the wedge is, we're doing this little thing on our website, what's the big deal going to be? And to an extent, that can be correct if it's something that's very small, very constrained, and doesn't have very much impact. But if it doesn't have very much impact, it's probably not going to have very much value for your company. So it's something you need to keep an eye on all the time. And it is, I don't have a nice, do this and it'll be fine, because there isn't a good answer to it. It's something people need to be consistently worked on, improving on. I went to a talk run by Open Data Manchester last year, I think it was maybe the year before, where Sapphire Nobel, I hope I'm getting her name right, could get it in the show notes later on. She's written a book on this. She's based in America, and about how so many different people, primarily women from underrepresented minorities, but all kinds of people have been adversely affected by machine learning algorithms in all walks of life, because people don't understand both the training data that goes in and what actions are being taken on that. So there was a relatively famous investigation that was done into predicting probation. It's something to do with probation in US prisons. Who's going to end up in prison? Who's going to be allowed on probation? What sentences should be? Stuff like that. And basically, an awful lot of important features that people use were basically what's the word? They were incredibly highly correlated to race. So basically, it was, if you were a young black man, you were going to be treated much more harshly than someone who wasn't, for no reason other than that's what the training data said. There's a similar thing with Amazon's hiring practices when they try to use AI to determine who should be recruited, and an awful lot of it is because the training data in the past has been trained on what is essentially racist behaviour, and it can be from small individual incidents which almost may not seem like an incident, but over the course of millions of examples is a very strong pattern. they really can impact real people's real lives.
So making predictions on historical data, where actually in the future the historical
we have
data
historical
won't repeat.
bias already.
Well, the bias is already in there. It's not
Yeah.
necessarily historical, but the bias is already there. So
Yeah.
if you're not keeping that careful eye out, one useful thing I think that people can use when they're trying to make predictions is when you're training your model, taking out, looking at specific slices of data. So, for example, what's the gender bias split? Are we getting massive amounts of false positives for women as opposed to men? How does that impact in a business use case? What would be the impact if we took this live?
Yeah.
And thinking through that, and while it may be optimal financially, are there risks and impacts there that are going to affect real people? Do we need to say, no, this model isn't ready for production? We need to be aware of that.
Right.
It has to be incredibly contextual based on whatever the situation is, I guess, and that's this thing data scientists are finding themselves they have to do when they start a company or join a company or whatever. Their job mainly isn't data science, it's to become this like business transformation expert, because now data is going to be a core part of this company. How do we use that in an ethical way? I think it's a really tricky question to answer this, because I need to reveal some opinions I have on government rule and stuff like that. But if we're going to regulate something like the use of data, those regulations need to come from a place of expertise. What we currently have at the moment with things like GDPR is we can protect. Is it protected fields or something like that? So you can't, in models and stuff, you shouldn't be using, gender or race as a feature. But like John says, if address is allowed as a feature, maybe that address is indicative of race already. And there's a what was it? Oh yes. So in Europe, you've not been able to do it for a while. You can't use gender to change the way you price or anything like that is discrimination. So if you wanted to, for example, have car insurance and you knew that 60% of your customers are men, 40% of them are women, men should get priced higher for car insurance because they're much more likely to get in a crash, despite whatever stereotypes there are.
Yeah.
But if you use that part of the form that says this is a man, so you should be able to increase the cost of that car insurance for that person. Instead, they can get around that, and this is the problem. You can regulate, but if we can still get around it, it's not really a regulation. So if you have some other method of predicting whether or not those people are male or female, then you can change the price for everyone so that it represents that 60-40 split, so that everybody is priced fairly, but now you're still pricing the men higher, but the women are paying for it, which doesn't really make sense.
Okay.
So for example, if you have access to shopping data, for example, there are products that men are much more likely to buy than women, that like men's Gillette razors over the women's Gillette, so much of our product is gendered already. So it's really easy to perform clustering and say we have two types of customers in our supermarket. We have group A and we have group B, and that's legal in Europe. But the moment you say group male, group female, now it's illegal. So we need, if we're going to regulate it like that and try and protect ethics from that avenue, there needs to be something much more intelligent in place.
Yeah, it's a complicated thing. You can't take data ethics aside from business ethics and the broader being ethical in general. But it's definitely something that people need to be aware of and actively improving on.
Yeah, I would like to hope, as individual data scientists, we sort of challenge our work and we ask ourselves, is this work we're doing ethical? Could this be used in the incorrect way? Obviously that's not how business works at all, so I'm sure loads of people will prove me wrong, but it would be nice if the regulation wasn't necessary.
Talking back earlier about interviewing candidates, that's part of something that we're going to work together on. What you posted today about relevant tests for candidates.
Yeah.
We see it regularly. We send a CV profile to a client having taken a job description. We've checked with the candidate, we've maybe interviewed them, we can see where they've worked. We might not be able to take references at that stage, but then we send a CV and there is a process where the client says, okay, or the company says, right, we want to do a test.
Yeah.
What's your opinion on the test that kind
I'm
of...
so prepared for this one. So I wrote this blog post today about why I disagree with these take-home tests. And I even provide 4 solutions of what you could do instead. So in technology, not just in data, front end, even in marketing roles, it's common to have this pattern of you send a CV in, you get no response, maybe you don't even know you've submitted the CV, you may have put it into a custom form on that website, so you can't just upload your CV, you have to copy and paste bits in. That's all super frustrating, and now you might not even get a response. I think that's all bad. Next step is a phone interview. Some people are really uncomfortable with phone interviews, some people love phone interviews. There's not much choice otherwise, but really at that point you're trying to gauge whether there's a personality fit, in my eyes anyway. I may be totally wrong because I've not seen this from the recruitment side of it. Then after that, it's very common to get what's called a kata, or a take-home task. I assume they use kata to make it sound very cool in software development, but a kata is from martial arts, it's like a rehearsed set of moves so that you can perfectly hone some sort of skill. So really, it should be something in software development that we do over and over again to make sure that we understand patterns or a good architecture or a good solution to a problem. It's not really that. It seems to be a way to offload a large amount of work onto somebody who's probably in a disadvantaged situation. They might be made redundant, they might be hating their job at the moment and need a way out, and then the company will often say to them, here's a task, please don't spend more than 2 hours on it. And that sort of wipes the ethical slate clear, because they're saying don't spend more than 2 hours on it. So if I choose to not spend more than 2 hours on it, that's great, but it's not going to be my best work. If there's one other person applying, you can bet they've spent 40 hours on it and they've probably done something fantastic, so I can't do 2 hours. So I've now done multiple hours work, potentially filling in all this. Then after that, normally you go in and they'll look at it with you and they'll review it together, but they might review it beforehand. So up until this point, I may have done 40 hours of work. The company has written the job spec, which they might have had before. It should just be a much more efficient process in my eyes. And I honestly think with some really intentional questions, you could get more than you can get from the kata. Or I think you should offer to pair program with them on a problem you already have, and then at least you're taking away, there's so much mental effort that goes into understanding the problem, understanding the context, and sometimes that context or problem doesn't make sense or isn't provided. And when we've done katas in the past, you'll look at it and you'll go what does this data mean, or what does this column mean? How should I be treating this? And at the end of it, I always think I would never work this way. I would never commit my code like this. I would never present it in this way. It's not a reflection of a real world situation. And then what's the point of the interview, right? The whole purpose of the interview, in my eyes, is assessing your proficiency for the job. And I think the important things there are checking what skill level you're currently at and how willing you are to learn a new skill. So I think instead of a kata, the best question I've ever been asked in an interview was, what's your opinion on linting? So linting is this sort of like an automated tool that checks if there's any errors in your code or any styling inconsistencies. So it's excellent for working in a team to make sure everyone writes the same kind of codes to solve the same kind of problem, and it doesn't break before anyone tries to compile anything. So that's like a kind of advanced tool that's totally optional. But what you get there is when you ask someone what's your opinion on linting, you get sort of 3 options. You either get, I don't know, maybe 4 options. You get, I don't know, which is fine. You get someone who lies and pretends they know what it is. Bad. Don't hire them. You get someone who says, I don't know, but can you tell me? And then you know this person's actually willing to learn. And then the 4th one, you've got sort of more senior level who say, oh yes, we use linting because it enforces this. It's really helpful in team because it does this. Now I know a lot. If I had a kata that they sent me that they spent 40 hours on, I probably need to spend half an hour to an hour to go through it. Why don't I just ask a 5-minute question? So I think there's a lot of problems in the way it's done at the moment. I really think it comes from a lack of expertise in that industry. And you've got to think, because of the way data science is at the moment, a lot of companies are hiring the first data scientist, and they're thinking, how do we hire the first data scientist we're ever going to hire? We've got the internet, so we Google how to hire a data scientist, and now you're in trouble, because now it'll say, now it's going to be full of opinions. It's not going to say, oh, data science is actually 6 different jobs. There might be example job specs that are going to ask for multiple years and whatever. And at the end of it, nobody at your company is a data scientist. So you don't know what tool is right for the job. If someone comes in and says, I've got 7 years AWS, and on your job spec you wrote 2 years Google Cloud Platform, that's probably a great person to hire. But you have no idea. So there's no specialty there. So I think there's a huge gap for companies to sort of take liability there and say, I don't know how to hire a data scientist. And from that, speak to people like you, John, and me.
Yeah.
And we say, here's how you hire a data scientist. Here's like a 10-minute talk. This is what data science is. Are you sure you need it? And if they say, yeah, we think we need it, then you go deeper and you say, why do you think you need it? And if they say, because data science is cool, I've seen it everywhere, I read a blog post, these are all like red flags. You need to have something more than I need to be cool, I guess.
Yeah. Yeah.
So yeah, that's my opinion.
Oh, I like it. Drop mic.
Yeah.
Excellent. Listen, that's been great. I think we've covered everything.
Yeah, okay.
Is there any questions you want to ask me? Do you think that we've got everything?
I mean, I think we could sit here and run for an awful lot of time about various things like data science.
Listen, it's been great having you here today, guys. Really, really appreciate it. It's been lovely talking to you about all things data science, and I've learned a lot today, and hopefully everybody watching the video will pick up something at least. And thank you very much indeed for coming along.
Thank you for having us.
Yeah, lovely.
Thank you very much.
Cheers, John. Thanks, Joe. Lovely stuff.